Okay, we are back in business. All right, now, this is Water and Aqueous Systems Tests Review Part 2. Good. Okay? Can I erase some of this stuff? Yes? All right, let me just erase this. All right. You wrote down what's up there, right? Who wrote down what was up there? All right, thank you, Master. Ellen, did you?
Yes,
You did?
yes.
But you didn't think you would tell me? You just thought you'd sit there and not tell me? Give me that stare, that 100-yard stare. Okay, so let me ask you this. What has a higher surface tension? Water or a seriously nonpolar liquid? What has what? What was the question? What has a higher surface tension? Yeah, exactly. Water has a very high surface tension. And what causes the water surface tension? Hydrogen bonding. And what does a surfactant do? It lowers what? Hydrogen bonding. And I may throw some questions on the test that have to do with laundry. Wrinkles. Yeah. Yeah, what does a fabric softener do? Yeah, so that they reset, so that when it comes out of the washer, you don't have all of those, it keeps the hydrogen bonding to a minimum, so things don't get as wrinkled. Yeah. But I have that on my lecture on laundry. I did a lot on laundry. You're laughing at me, Dennis? That's the best you can do? No. Yes, laundry. How many people do their own laundry in here? Raise their hand. One person is raising their hand. You guys don't do your own laundry? One person? Diego, are you being honest? You do your own laundry? Yeah. You do your own laundry? 2 people out of a class of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Man, it's more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 2 people out of 14, that's pretty terrible. Giving laundry to my mother was like giving clothes to the Goodwill. You never saw them again. So if you ever wanted to see her clothes again, you did them yourself. And she purposely would hide them. Yeah. I'm doing your laundry? I don't think so. And my kids at home? No, my mother was very much nicer to that. My kids knew how to do their own laundry. They'd make a mess sometimes, but they could do their own laundry. All right, now, so a lot of things. Now, let's talk about what's the geometric structure of water. Let's talk about that. How do we actually get that? We know that it's bent. We know that it's approximately 105 to 109.5 degrees. The hydrogens are apart from one another. But let's determine, let's go back, way back, as Mr. Peabody used to do, to chapter, whatever it was, 8 on geometric structures of molecules, okay? So let's do water. Okay, we know that water is going to look like this. Okay? So what you do is, now this is very important when you're talking about the polarity of a solvent, for instance, right? So you need to know if something's going to be polar just by looking at the formula. So you really have to know chapter 8 and chapter 15 together, correct? Okay. We know this is going to be 1, 1, 6, that's 8, right? Each bond is what? 8 minus 4, this is the bonds, right? Is 4. These have everything satisfied. They have the valence satisfied because remember, the hydrogen wants to be like helium, so it's 2, the nearest noble gas, correct? We don't say the octet rule. Right? That's for aliens who don't think as well as humans. So we say octet rule for them. But Massa, you're not an alien, right? Excellent. Okay, so therefore we have 4 left over, and you're going to put them on the central atom, correct? Now remember, when the electron's left over, you put them on the central atom. Now this is the rule. If you have a central atom that's a non-metal, how many electrons must, what's the minimum number of electrons a non-metal central atom will have? 8. Minimum. Can it have more than 8? Yeah. For instance, xenon could have 6. Could have 6 unpaired electrons. Xenon can have that. Xenon difluoride. Okay? We'll do that one next. Xenon difluoride. Okay? So this is going to knock these out, correct? So this is going to look like this. Yes? So that's why that shape is polar. Correct? So you have a dipole going like this, you have a dipole going this, and they don't cancel. Yes? Do you get it? You understand? Let's do, is that okay? Simon, you with me? You're sure? Okay. Let's do another one. All right, let's do this one. What's that called? Use the Greek prefix system. 1 left component. You know, you don't use any prefix. So carbon. 4 for chlorine. No, it's binary, so it's going to be IDE, right? So carbon tetrachloride. Okay, it's a very, probably one, I think, one of the better known solvents, organic solvent. It's not really an organic solvent, but it is a non-polar solvent. It will dissolve organic substances, but I wouldn't call it organic necessarily. Okay, it's organic maybe because of carbon, right? But it's like this. So you put your right? You put your 4 bonds there, correct? You count up your total valence. So this is going to be 1, 2, 3, 4 times 7 is 28, plus 4, 32, minus 8, that's the bonds, right? And that's going to be what? 24, and then minus what? Minus 24 completes the valence. Right? You have 2 there, so you want to complete the valence, correct? Doesn't chlorine want to be like the nearest noble gas, argon? How many electrons does argon have in its valence shell? 8, right? Correct? So that's it. Any excess electrons on the central atom? No, there's none left over. Therefore, it is going to look like this, right? Are all of these, are all the dipoles, do they have an equal and opposite dipole, each dipole? That dipole has an equal and opposite. That dipole has an equal and opposite, etc., correct? Do all the dipoles cancel? Do they? Yes, they do. Therefore, is it a nonpolar or a polar solvent? It is nonpolar, correct? Yes or no? Let's do another one. Let's do chloroform. What's chloroform? Chloroform is CHCl3. Is that chloroform? CHCl3. Is that chloroform? Look up chloroform for me.
CHCl3, yeah. It is CHCl3.
Can I have Can I have CH3Cl? Sure, I can have that.
Chloromethane.
Yeah, chloromethane. Dichloromethane. Trichloromethane, which is chloroform. Clear? Carbon tetrachloride, which is here. Okay, so this one right away, you know you're in deep trouble here. Why? Why? The best case scenario is, oh, we got to go. The best case scenario is, look at this. Is that going to balance? Is it? Let's do it quickly. So this is going to be 21, 4, 1, 26, correct? Minus 4, 22. Complete the valence, right? What did I do? Minus 8, sorry. Minus 8, I have 18, right? Complete the valence, 6, 6, 6, right? 0, none on the central atom. But this has a dipole like this. This one is like this. Will that one cancel? No. Therefore, this is polar, because that's a polar molecule. All right? Study well. We'll put review 3 on, so I'll finish next period. Clear? Go have some lunch.